So here we have a sphere with radius r, and what I want to do is find a cone with the largest volume that can fit inside the sphere. And so that's what this video is about. So once again, the radius of the sphere is r, and so the distance from here to here be r, and then the distance from here to here also be r. And then let h be the height of the cone. And then let r sub c be the radius of the cone. And so the distance from here to here will be r sub c. And then the distance from here to here will be h. And r, once again, is the radius of the sphere. And now look at this right triangle right here. So this length will be r, and then this length will be r sub c, or the radius of the cone. The distance from here to here is h. The distance from here to here is r, and so this part right here will be h minus r. We know that the volume of the cone is 1/3 times pi times the radius of the cone squared times the height of the cone. And then from this right triangle, we have h minus r squared plus r sub c squared equal to r squared. And then simplify, we have h squared minus 2hr plus r squared plus r sub c squared equal to r squared. And then minus r squared, then we end up with h squared minus 2hr plus r sub c squared. And then move these two terms here, move them to the right side. Then we have r sub c squared is equal to 2hr minus h squared. Once again, the volume of the cone is 1/3 times pi times r sub c squared times h. But r sub c squared is 2hr minus h squared, and then times h. And then simplify, we have 2/3 pi h squared r minus 1/3 pi times h to the third. And we want to have the largest cone that can fit inside the sphere. And so to find the largest, we will take the derivative of v sub c with respect to h. And so this is derivative of the volume of the cone with respect to the height of the cone. So here we're taking derivative with respect to h. So the derivative for 2/3 pi h squared r will be 4/3 pi h r. And then for this term, the derivative will be pi h squared. And then set the derivative equal to 0. So we have 4/3 pi h r minus pi h squared equal to 0. Divide everything by pi h, then we have 4/3 r minus h equal to 0. Or h, the height of the cone is equal to 4/3 times r. R is the radius of the sphere. And now we will use this relationship to find r sub c. squared. So we had this relationship right here, r sub c squared is equal to 2hr minus h squared. But h is 4/3 r. This term we will get 8/3 r squared. And then this term we will get 16/9 r squared. And then we end up with 8/9 r squared. The volume of the cone is 1/3 pi r sub c squared times h. R sub c squared is 8/9 r squared. H is 4/3 r. And so we end up with 32/81 r to the third. And therefore, the largest cone that can fit inside the cone with the largest volume that can fit inside the sphere will be 32/81 times r to the third, where r is the radius of the sphere. And that's the end of the video.